We are so close to the end. So close. So close. We're at chapter 9 of CCNA 2. One more chapter left after this. This one's relatively short on network address translation. That's what NAT stands for, and it is network address translation for IPv4 because really no official network address translation is happening for IPv6. Really, there is one NAT concept we need to discuss for IPv6. But mostly it's IPv4, just a couple slides. But it can be a little bit confusing of a topic. So we're going to go into NAT, explain the differences between static, dynamic, and something called port address translation, which is kind of a Cisco term, not really a networking term. And we'll discuss what that is in just a moment. So that's what we have going on. Only a couple slides, like I said, but if you don't understand previous topics, this can be a little difficult. So, NAT operation. We're going to take a look at our private IP address space, which we have addressed before. You've got your 10 address space with a /8, your 172.16.0.0, and your 192.168.0.0 address spaces that are reserved for private IP addresses. So what NAT is and why those private IP addresses are important. Well, first of all, we've talked about how they didn't anticipate so many devices needing IP addresses when they made IPv4, so they were going to run out, and private address spaces helped alleviate that, basically allowing you to have one public or officially registered IP address and a bunch of private IP addresses that are behind that public IP address. So where you might have, I don't know, 50 different devices, you've only got one official public IP address, registered IP address for them. The rest of them are private inside your network. Network address translation turns a public IP address into a private IP address, okay? And the process that goes on there. It could be static NAT, dynamic NAT, or port address translation, which is what we use in our home networks. So you'll see that in just a second. So NAT terminology, which I've been told I'll know next week if these are official test questions when I take the test myself. This NAT terminology apparently comes up in tests quite a bit. So it's important to know that your inside address and outside address really aren't the terms that'll come up. It's your inside local global, outside local global. Okay, and probably the easiest way to remember this is that inside is always referring to your network. Outside is always referring to the destination network, okay, or destination device. Okay, if you think of it that way, if you remember it that way, then figuring out the other part should be kind of logical, in that if you have an inside local address, that's probably your local address or private address inside your network. So in this example, we have a PC1 here. Its inside local address is going to be 192.168.10.10. That's your private IP address inside of your network. Okay. Your outside local address is going to be your address, your outside, sorry, see, I'm messing up myself. Your inside global address is going to be your public IP address. Okay, you can see how it might get confusing, and you might want to call your public IP address outside local because it's like local to you, but that's not the case. Again, inside's always your side of the transmission. Outside is always the destination side. So again, let me go ahead and do this again. Inside local, that's your private IP address. Inside global is your public IP address. So you can see in the example here, 192.168.10.10, that is your inside local address, designated here. Your inside global is your public IP address out here, which is 209.165.200.226. So you'll see that here. Okay. Those are what are important to us configuring the network. When we set up network address translation or NATing, the other side we don't even have anything to do with. That's the destination network's problem. It's not our problem. It's not anything we need to set up. But the same thing would be true if they were using NATing. And I don't like this slide so much because it's a little confusing that the outside local and outside global addresses are the same, because this network on the other side of the topology is not NATing. Okay, it's not using NAT. So if they were, you would have a different outside local address, which would be their private IP address for the web server, and then they'd have a different outside global IP address, which would be their public IP if they were using NATing. They're not. Since there's no NAT taking place, they're both the same. Okay, hopefully that is clear. Hopefully that's clear after me messing up one time. So the types of NAT that we have static NAT, dynamic NAT, and port address translation, or PAT. Okay, and this is where things get a little, well, a little tricky for us as Cisco types communicating with the outside world, in that static NAT is always the same. So static NAT is going to take, hopefully you can see this pretty well. It doesn't look like you can. Let me see if I can grab a better graphic. One sec. Alright, well, here is a better graphic for the static NAT. So static NAT, what you're going to be setting up is you're in a scenario where you have multiple public IP address or inside global addresses. Okay, and you're going to map those public IP address or inside global addresses one-to-one with private IP addresses inside local addresses. Okay, there's no sharing of an IP address. Each public is matched with one private IP address. So public, private, public, private. You're not really adding more than one device to each public IP. Okay. So if you do have a server that you always want to be reachable through some public IP address, that might be a scenario where you just one-to-one map. Every time a client is trying to reach your server, they go to this public IP, and that's the only place that public IP leads is to your server. Okay, so you just map these on one-to-one basis. This is not what we use in our home networks or small office, home office networks. Okay, so again, static is just mapping one private address to one public address. Okay. So one-to-one mapping configured by the network administrator remains constant. There's no jumping around, and they don't dynamically configure like dynamic NAT would. They just stay put. They aren't dropping addresses and adding new addresses. That's what's going to happen in dynamic NAT. Okay, so you do set up a pool. You set up a pool in dynamic NAT, and as devices come online, they are going to take up an address, a public IP address in that pool. So let me see, I'm pretty sure I have a graphic of that as well. Here we are. So you've got a pool of public IP addresses that you set up as available. Okay, and as devices come online, they'll end up being tied to one of these public IP addresses. So this 12 computer is tied to this address here. If PC2 comes online, it's going to take up this slot and grab this address. Okay, PC3 or server comes online, it's going to take up that address, and they'll become available and unavailable dynamically as devices connect and disconnect from the network. Okay. Again, this is just a one-to-one mapping. You're not using multiple inside local addresses along with one public IP address. It's just one inside local, one inside global, one inside local, one inside global. Okay, it's just they're mapped dynamically. You're not statically going in and saying this address is always tied to this public IP address. This private IP address is always tied to this public, and that's the way it is permanently. Dynamic, well, dynamically allocates based on who's there first, basically, who takes up a slot first. All right, so public IP addresses that are tied to private will be changing in this situation. Okay, not something that's set up all that often. What is set up more often is this port address translation, and here's where things become a little different. Let me make sure I didn't miss anything back here. Use of the public, okay, requires that enough public addresses are used in use. So yeah, you do need more than one public IP address for Dynamic NAT. Okay, that's not the case with PAT. Okay, that's port address translation. This is where you can use a single public IP address for multiple private IP addresses. This is the situation that you come up with at home. There's a text message. Maybe I should silence that. Maybe a good idea. Okay, let's do that. And silenced. Good. Moving on. Of course, I'm not going to go back and edit this thing, am I? So anyway, Dynamic NAT and port address translation. Port address translation is what the rest of the world calls Dynamic NAT, but Cisco calls it port address translation, which is just a Dynamic NAT with this overload feature turned on. They're almost the exact same setup process. It's just that port address translation is able to map multiple private IP addresses to one public IP address by using ports to keep track of traffic. Okay, so we'll take a look at that a little bit more later. That's basic. That's the basis of it. You're using ports to keep track of traffic. So if you have a source port of, we'll say, 1102, it has to be something above 1023 because those are your registered ports. So you have a source port on a packet that you're sending out of 1102. Okay, it goes out onto the network, goes through the NATing process, and when that packet comes back with a destination port of 1102, the router then knows it's for your device based on the port number. Okay, it creates those sessions or sockets based on the port number, and that's how traffic travels back and forth. And you're allowed to have multiple devices that share one public IP address because those conversations are being tracked by port number, and you can manage traffic that way. Okay, so we'll see that a little bit better as we go through the slides. On this slide, we have some advantages and disadvantages of NAT. On the advantages side, of course, it does conserve legally registered addressing scheme, or the legally registered addressing scheme, by only using limited public IP addresses and a bunch of private IP addresses. That also gives us flexibility. You can connect any private IP address to a public IP address, or multiple private IP addresses to one public IP address. Provides consistency for internal network addressing schemes. Instead of having a bunch of public IP addresses on your network, you've got a bunch of private, and that's a lot easier to manage. It would require a lot more work to rearrange your network if you were dealing with public IP addresses only. It does provide some security in that it hides your actual IP address from the outside networks or the internet. It's not too great of a security feature, but at least it doesn't let someone know exactly where you are, like IPv6, for instance, would. Okay. Disadvantages: performance is going to be degraded to an extent. Processes that require higher quality of service. That's right, QoS. will be more impacted by this in that there's going to be some calculations that need to go on to translate from a private IP address to a public IP address. Not calculations, but a process that needs to take place, and that's going to slow down traffic just a little bit. And if your process does require high quality of service, that can degrade your performance to an extent. It typically doesn't produce any noticeable effects, but it will slow you down just a little bit. End-to-end functionality is going to be degraded. There are going to be some processes that require end-to-end addressing, and with NAT it's just not going to work because you don't have a true end-to-end addressing scheme. So certain processes just won't work with NAT. Very few, but some just won't. End-to-end IP traceability is also going. If you have multiple NAT hops going on as your packet travels from the source to a destination, it can make tracing it a challenge and therefore troubleshooting more of a challenge as well. Tunneling is going to be more complicated because NAT modifies values in headers, and initiating TCP connections can be disrupted unless your device has been set up to be able to handle certain protocols in TCP via NAT. So that'll be something you have to set up for some TCP applications. Okay, so those are your advantages and disadvantages. Now we move on. I think we want to move on. Okay, to configuring NAT. So configuring NAT, we've got three different types. We've got static, dynamic, and PAT, or port address translation. We'll start off with static. This will be the easiest of the processes to set up, static NAT, in that you're only linking one private IP address to one public IP address, or one inside local address to an inside global address. Okay, so what you're going to do is set up your IP NAT inside source static, then give the local IP or the private IP inside local to the global or public IP. Okay, so you just type in the private IP, public IP. Then you need to determine which, and I know these commands don't really line up with the naming scheme, because you do an IP NAT inside on the interface on your router facing the inside network, and an IP NAT outside facing the outside network. And that's kind of confusing with this inside global, inside local jargon down here. So that hopefully that doesn't trip you up too much. You got some commands to verify NAT down here that we'll take a look at more when we get to the troubleshooting section at the end of this chapter. So seeing these commands in action, you're going to go to your router that you're setting up NAT on. You can see our inside network, and here's the server that we want to perform NAT on to be linked to this public IP address. Okay, private IP address, public. So we do IP NAT inside source static. Okay, then we give the local or private IP address, which is the IP address of the server, which is going to be translated to the public IP address here. So 209.165.2.1.15, that's our public IP address. So we set that up in, well, that's all we need to set up the NAT. Then we need to place it on the interfaces we'd like. So we go to an interface, give it some IP address. This IP address really inconsequential here. You're just giving the interface the IP address that it needs. And on that interface, you're doing IP NAT inside, if it's the interface, which it is, S000, facing your network. Okay, IP NAT inside, or the network in which the private IP address exists. Okay, that's the inside NAT, IP NAT inside. Then the opposite, you're going to go to interface, the other one facing the outside network, S010. Again, this IP address is what it is, okay? And you're going to know IP NAT outside to apply it to that interface facing the outside network. All right. So that's what you got there. That's how you're going to set it up. So you set up the network address translation, what translates to what with this command here, IP NAT inside source static, blah, private IP address and public IP. Go to the interfaces facing the inside network, IP NAT inside, the interface facing the outside network, IP NAT outside. And that's how you will set up a static NAT. Alright, so that's static. We've got dynamic here. So, dynamic, rather than being a one-to-one, okay, like static, you're always going to have the same private IP address tied to a public. You're going to have a pool of public IP addresses that will be assigned to devices inside your network on a first-come, first-served basis. Okay, and again, that's one-to-one. You're not using multiple multiple private IP addresses on one public. Each private IP address requires one public IP address in this scenario. Okay, so not the best technique to use, and which is why it's rarely used. So here we go. Anything else? Oh, if there's no more addresses left, public addresses left in the pool, and some device in your network tries to request one or get on the network, they aren't going to be able to communicate. Okay, because all the addresses inside the pool are gone. So that's gonna happen. Going on down. To configure this, well, maybe this doesn't look the greatest to you. So what you've got here is, well, the commands, but not written out in command line, which might be a bit easier for you to read. But essentially, we need to create an IP NAT pool. Okay, we've created pools before, like a DHCP pool, which is going to contain the range of public IP addresses that are going to be available for your private devices to be assigned to. Okay, so you're going to type in IP NAT pool, the name of the pool, okay, whatever name you want to give it, then the first public IP address in the range and the last public IP address in the range that are going to be given out. Okay. The extra thing we need to do here is usually we would just type in the subnet mask. This is one scenario where you can use the subnet mask or your prefix length or CIDR notation instead. The downside is you need to define which one you're going to use. So if you're going to use the subnet mask, you have to type net mask, then the subnet mask out. If you're going to use the prefix length, you're going to have to type prefix length and the / whatever prefix length. So not the most fun in the world, but that's what you have to do. Again, IP NAT pool, give it a name, start of the public IP address range, end of the public IP address range, and then either net mask or prefix length to set that up. Okay, so that sets the range of public IP addresses. Then you need to determine what private IP addresses, okay, are going to be able to access that pool. And you're going to create an access list for that. So it's just like the access list we created before. You can give it this access list a name, a number, permit or deny, however you want to. And whatever access list you create, whoever's permitted in that list will be given access to the pool. Okay, so we create our access list, and just like a normal access list, you have to have at least one permit. You're probably going to have a range of permit. Maybe a network excluding a couple of addresses or something like that. Okay. Once you've made your access list, you made your pool, you're going to come on down here. You've got IP NAT inside source list. Okay, and you type in whatever the access list name or number is here, then pool, and that pool name. Okay, so that's how we're going to set it up. We'll use access list number in class. So again, IP inside source list, access list number, pool, and then the name of the IP NAT pool that you created up here. All right, hopefully that's clear. Then you're going to do an IP NAT inside, IP NAT outside, just like we did with the static NAT configuration. Okay, so moving along, here's what the pool would look like. Actually, let's take a look down here. Here's what the commands would look like in command prompt. Okay, so you'd have your IP NAT pool. We just call it NAT pool 2 here. And you give the range 209.165.200.226 through 240. Okay, net mask, whatever the subnet mask is. They created an access list that would permit this network to use addresses from that pool. Okay, and then you have to do, well, we would do the IP NAT inside source list 1, the access list 1, and the pool would be NAT pool 2. We don't do the overload for this part just yet. This is for Pat, but this is the only slide I have to give you on Dynamic NAT. So you don't do the overload part for Dynamic NAT, but really it's the only thing different between Dynamic NAT and Pat. Okay, so let's ignore that for now. Then you come down to your interfaces and do your NAT inside for the side towards your network and the NAT outside for the side outside. Okay, so again, NAT pool, give it a name, range. If you're going to use a subnet mask, you have to type in net mask and the subnet mask. Access list, whatever, and do your permit here. Okay, and then IP NAT inside source list, whatever the access list is, pool, whatever the NAT pool is that you created. Okay, so that's how it'll look. It'll be a little something like this in that you've got a range of public IP addresses, and as your devices connect, they will be able to use those public IP addresses that are available. If there are none available, then your device is not going to be able to communicate over the internet or outside the network. So that is something that will happen if you run out of addresses. So that's Dynamic NAT. You need to know about it. It's not used as much, but that's how it goes. So again, here's some analyzing and showing the IP NAT translations, blah, blah, blah. We'll talk about these in troubleshooting once again. Alright, here we have configuring your port address translation, which is going to be different in that you can have multiple private IP addresses assigned to the same public IP address. That was not the case in Dynamic. That is the difference here. Okay, the traffic is kept track of by port number. That's how come you can share the same public IP address. And it's set up the same way, even though this slide does, yes, it is missing a step. So what we should see here is you should see overload at the end of this. I'll just discuss that in a second. So it starts off exactly the same as Dynamic NAT. IP NAT pool, starting IP, ending IP. Okay, then the net mask, yada yada yada, all the same. Access list, make an access list to determine who's going to be able to get IP addresses from this pool. Same as Dynamic. This is the same. IP NAT inside source list, give it the access list number after that, and then pool, whatever you name the pool. After that should come overload. I don't know why it's missing from this slide, but it is. Overload should be written out here after the name of the pool. That lets you know that you can overload or assign more than one private IP address to a public IP address. So here's how that would work. You're going to have, let's say we have 5 different public IP addresses and 20 clients that need private or that need with private IP addresses that need to be assigned public, but through NAT. Okay, so again, 5 public, 20 private. The first 5 devices that connect are going to be attached to those 5 public IP addresses. Okay, but the 6th one is going to be given the first public IP address, and it's going to be set up through port address translation and use different ports to control the traffic. All right. The 7th device that would connect would also use the first public IP address. The 8th would also use the first. What happens is after you run out of public IP addresses, the following devices that try to connect, they all stack up on that first public IP address. It's not like they're evenly distributed. Okay, so that's something kind of important to remember. If you're using a range of addresses for port address translation, is that you will end up with multiple devices on your first public IP address. All the rest of your public IP addresses will just have one device or one private IP address attached to them. Okay, so that's how it's going to work. Of course, we have our IP NAT inside and IP NAT outside that we configure, so you got that there. And this is again using a range of public IP addresses. If you just want to use a single one, it's a little different. Okay, so if you're using a single public IP address, you're going to need to use the IP address of the outgoing interface that is on your device. That's what's going to end up happening. So we no longer have that NAT pool that we needed to create up top. We're just going straight to an access list. Which list do you want to be able to receive, or do you want to be able to use NAT to have their address tied to whichever public IP address? It's going to be this one, for instance. Okay, so make your access list as normal. Excuse me. Then IP NAT inside source list, give that access list number of the list you just created up here. Okay, then you have interface type. Then you need to go ahead and type in the name of that interface. So in this case it would be S01 or S010. So if I'm reading this out as it would be typed in a command line, it would be IP NAT inside source list 1 interface serial 010. Okay, then overload. That's what this command line would look like. All right, because we're using a specific interface, and that interface is tied to the IP address that we're using through NAT. Okay, the outside, sorry, not outside, the inside global address or the public IP address. And then we assign IP NAT inside, IP NAT outside as we normally would, and that's it. Okay, so when you're using a single address, you're going to actually label the interface in the IP NAT inside lists entry. Okay, rather than naming a pool. You don't create a pool. You do not create a pool for a single address. You just designate an interface that has the address on it that you're going to use. Okay, so let's take a look at, actually, this is how the first example of PAT would look, port address translation. So again, it's very similar to NAT and then Dynamic NAT. And this is the slide I used as an example for Dynamic NAT, if you remember all that time ago, a few slides back. So we got IP NAT pool. We gave the first public IP address, last public IP address, subnet mask or net mask, and the subnet mask here. Create your access list of, that's going to designate the private IP addresses, okay, that will be given public IP addresses through NAT, okay, or assigned public IP addresses through NAT. Then we have to set up and bind the NAT pool to the ACL. So we go IP NAT inside source list 1 because this is access list 1, NAT pool 2 because this is NAT pool 2, And the overload command is the command that allows you to have more than one private IP address assigned to a public IP address. Okay, and then we go to our interfaces, NAT inside, NAT outside, and done. Okay, so that's how it goes. If this were just one public IP address, then after we have IP inside source list 1, we would just type interface serial 010, then overload, rather than NAT pool or pool not pool. We would just wipe this pool NAT pool out and type in interface serial 010 overload instead. Okay, hopefully that registers and makes sense, some sense at least. Okay. So how this is going to work with multiple private IP addresses attached to one public IP address is that the conversations are kept track via port number. So in this situation we have PC1 and PC2 both using the same inside global address. Okay, they just have different port numbers. You see there's a colon 1444 here and a colon 1445 here. So here's what's happening. Okay, this traffic originates at PC1. Okay, source address of its private IP address, source port number of 14444. Okay, as that travels and gets natted through the R2, it turns into a source address of the public address and source port still of the same port. Okay, so that traffic gets sent to the server. Okay, the server replies back with the destination port, which is the same. Okay, 14444 to that public IP address. The router is going to know, since it's destined for port 1444 and that public IP address that is natted, it knows to send it to PC1. All right, hopefully that's all good so far. Here's where it gets a little different. So we've got PC2, which sends out some traffic to the server as well. Destination address or source address of this, source port of 1444. Because source port 1444 is already in use for PC1's conversation, or the socket. Remember that an IP address and a port number is considered a socket, so that socket is taken up, that port number is taken up by this conversation up here. The router will actually take that source port and give a different one. Okay, so it's going to use 1445 instead if that situation is to occur. All right, so the router does that itself through natting. It assigns a different port number to traffic that is destined to PC2 over here. All right, so now the source port number on this traffic is 1445 once it leaves your local network. Okay, so that is sent to the server. The server replies back with a destination port of 1445, also back to the same public IP address. It hits the router. It knows that if it's destined, because the router assigned it and is keeping a table, it knows if it's destined for port 1445 that it's supposed to go to PC2, which is this address over here, or this destination address here. Okay. The router also does change it once it's inside the network to the original port. Okay, so now inside the network, while the server generated the traffic, it was destined for port 1445. Once natting happens, the router changes the traffic before it reaches the PC to go back to port 1444. Okay, so that's how the router, your router, is able to keep track of conversations through port number and IP address. And remember, remember, port number and IP address together is a socket, so it's keeping track of conversations via sockets. Okay, essentially. All right, I hope that made sense. We'll talk about it more in class. Moving on to port forwarding. So port forwarding is the ability based on destination port and IP address to forward traffic to a certain device inside of your network. Okay, people do this for gaming and whatnot. If you want traffic to go to your server inside your network, always you can set this up. Okay, so if traffic is sent towards your public IP address to a certain port, you can have it forwarded automatically to a private IP address inside your own network, okay, and a certain port on that device as well. So let's see here what they have set up. The commands are, you're going to go ahead IPNAT inside source, same way we set it up, okay, and we've got static and then either TCP or UDP, okay, depending on what type of traffic it is. Then you're going to type in the local IP address and local port that you want the traffic forwarded to, okay. Then you're going to type the global IP and global port that you're going to receive traffic on to be forwarded. And the extendable is you could type in the port number. I'm sorry, the extendable is you could type in extra commands out here at the end here. Typically you're just going to stop right here. Okay, so here's how this would look. First of all, through command line, the commands we just saw. IPNAT inside source static, either TCP or UDP. Then the device in your network that you want your traffic forwarded to, so 192.168.10.254, that's the address of the server here. And it's going to receive that traffic on port 80, because it is a server, it's probably HTTP. Okay, and it's going to forward any traffic that it receives on 209.165.200.225 and port 8080. So this port out here, okay, if it receives there, or that address receives traffic on port 8080, it's automatically going to go to this IP address and to that port. Okay, that's what you're setting up, forwarding to an IP address and a port based on the destination IP address and port out here. Okay, your public destination IP address and port. Okay, so that's how it's going to work. Setting it up on the interface is the same as the other processes we discussed. Interface serial, that's it. Okay, NAT inside, NAT outside. On your home router, then it's a lot easier. You're just going to say what you want forwarded to where, external port, internal port, the protocol, and where do you want it forwarded to. It's as simple as that. So for application web server, external port 80. If I receive on 80, I want to forward to the internal port 80, protocol TCP, to this IP address here. So that's how you do it on a consumer router. The router that you have in your home has a function very similar to that. So we don't, moving on, configuring NAT for IPv6, we're not going to. We just need to be aware of how NAT is used in IPv6. Well, why we don't NAT is because we're not concerned about IP address space with IPv6 because, you know, that 340 and decillion addresses that we have available. So what we have in IPv6 is NAT 64, which is around to give us the ability to communicate between IPv4 and IPv6 networks. So it'll allow you to convert an IPv4 address to IPv6 and vice versa to allow communication between IPv4 and IPv6 devices. How? We don't need to know, we don't need to configure it or anything like that yet in this course, okay? So just know that it exists, NAT64, and it allows you to communicate between IPv4 and IPv6 addresses, okay? Or IPv4 and IPv6 packets. That's it, pretty much. Knowing the range of unique local addresses, which have the prefix of FCC00::7, which translates to a range of this. You may need to know for a test question, but I think that's about it. Okay, I'm almost certain. I mean, I'm not even sure if this is a test question. If anything is, it's going to be this and just what NAT64 does. Okay, so there's that, and we're almost done. Troubleshooting NAT. Troubleshooting NAT. We saw some commands that I said we'd discuss later, and later has arrived. So we've got the ability to clear IP NAT statistics and clear IP NAT translations, which is something you probably want to do before you debug or do anything else, so you have a kind of a clean slate to see what's going on in your network. So here, if you were to do your clear IP NAT statistics, clear IP NAT translation, that'll kind of give you a clean slate if you want one. You can do show IP NAT statistics to see, how much of your address space is allocated, how many translated packets you've received. You can see your pool down here in the range of the pool. So there's some useful information there. You can also do a show IP NAT translations to see what has been translated. What is your inside global connected to a outside global? All right. We don't really concern ourselves with the outside local, outside global. But we will be concerned with the inside global and the inside local. Then you can do a show IP NAT, a debug IP NAT, and you can see the translations that are going along with their port numbers that are assigned. So there's that as well. That will help you during, I don't know if we need to use debug, but you'll probably need to show IP NAT translations a few times in our labs. All right, so that's what we got. That's the end of our long 27 slide presentation.